lesson 20.9. So here we're looking at series with some positive and some negative terms. Okay, so we have a series. Hold on, actually, I need to do one more thing. Where's that file? All right, sorry, starting over. Okay, so 20.9, we're looking at series with some positive and some negative terms. So yesterday we talked about alternating series, and so that was positive, negative, negative. Okay, so this is just some positive or some negative terms. It doesn't necessarily have to be alternating. All right. So first theorem says a series whose terms are not all the same sign is going to be convergent. All right. So convergent doesn't talk about divergent if the absolute value series is convergent. Okay. So if we have a series that does not have all the same signs, we can test its convergence by determining whether or not the absolute value of that series would be convergent. If the absolute value of that series is convergent, then our series is also going to be convergent. All right, so that works for convergent. Theorem 2 is what we call the extended ratio test. You can see here, we can abbreviate extended ratio test as ERT. And so the extended ratio test, you're going to see, is very similar to the ratio test, but now we are finding the absolute value of the ratio of u sub n plus 1 to u sub n. So if in a series, again, whose terms are not all the same sign, so they're not all the same sign, then if we find the limit as n goes to infinity of u sub n plus 1 over u sub n, if that limit is either greater than 1, less than 1, or equal to 1, we can determine the convergence, divergence, or nothing at all. So again, equal to 1, we can't tell anything, just like the ratio test. Less than 1 is going to be convergent, just like the ratio test. And greater than 1 is divergent, just like the ratio test. So that follows basically the ratio test. And so it extends the ratio test to be able to be used not only for positive terms, but when the terms are not all the same sign. Okay, so it will work in the same way. We just take the limit of the absolute value here of that ratio from the ratio test, u sub n plus 1 to u sub n. All right, so those are the two theorems for 20.9. And let's take a look at a couple examples. So first one, so it says to investigate the convergence or divergence of the series with the terms having these specified characteristics. All right, if a series is convergent, we are going to test for absolute or conditional convergence like we did with the alternate series test. All right, so here we have the absolute value of u sub n is equal to 1 over n to the 4th. And it says that we have pairs of consecutive terms having a common sign that is alternately positive and negative. Okay, so positive, positive, then negative, negative, then positive, positive, then negative, negative, and so on. So all of my terms are not positive terms. All right, so I want to think about what's the absolute value of this series. And so if I would just look at the absolute value of the series, it's going to get rid of the alternating signs of the terms. So now I just have all positive terms. So I have all positive terms of 1 over n to the 4th. So what do we know about 1 over n to the 4th? Think about what kind of a series is 1 over n to the 4th. So you should be able to think about something that we've already learned and determine whether or not that series is going to be convergent or divergent. So think about that for a moment. All right, so we have a p series of p equal to 4, and we write out our sentence explaining that. So you can write out your sentence. And again, the absolute value of that is convergent, because that's what we just figured out. So it's going to be absolutely convergent. And so here is my sentence. Maybe you can do it sentence. Oh, come on. Okay, there we go. So the absolute value series u sub n equals 1 over n to the 4th is a p series with p equal to 4, so it converges. Therefore, the given series is absolutely convergent. And make sure that you do have that word in there, absolutely convergent. And that's number 1. All right, so we'll continue on to number 2. So number 2, we have the absolute value of u sub n is equal to 2 to the n divided by n plus 2. And again, with pairs of consecutive terms having a common sign that is alternately positive and negative. All right, so let's think about this one and how we could show that this is going to be either convergent or divergent. And if you remember, I said that when you have an n in the exponent, that a good test to use for that would be the ratio test. And so we're going to again use the absolute value. And so we're going to start by finding the ratio. So finding the ratio of the absolute value of u sub n plus 1 to u sub n. So go ahead and write out the ratio of u sub n plus 1 to u sub n. And then we plug in our numbers. And then we're going to multiply by the reciprocal and simplify, expanding out the 2 to the n plus 1 as 2 to the n times 2 to the 1. And I know I'm not showing any of this on screen right now because I want you guys to kind of work through it, because this is kind of taking what we've done already and putting it all together. So we're just utilizing all of the tests that we already know to work through this problem and the problems that we're going to be doing today. All right, and so when we simplify that ratio, we should end up with this. So we get the absolute value of u sub n plus 1 over absolute value over u sub n ends up equaling 2n plus 4 all over n plus 3. And then we need to find the r value. So to find the r value, we take that 2n plus 4 over n plus 3, and we find the limit as n approaches infinity. So go ahead and find your limit as n approaches infinity. All right, so our limits, here's the work for the limits, and we got r equals 2. And so then, based on the fact that r equals 2, we can look at our extended ratio test above. And so r is going to be greater than 1. And so we will say that this series is divergent. Now we're going to go ahead and we're just going to write that out in a sentence. So our sentence, something like this: since r is greater than 1, the series absolute value of u sub n diverges by the ratio test. Therefore, the given series also diverges. And there's number 2, and that is lesson 20.9.